Two AP questions. The first one asks for the derivative of the absolute value of x minus 3 at x equals 1. Okay, so we haven't really talked about how to take the derivative of an absolute value. There is a way, but it's to break it into the piecewise function. So we're not going to do that. This is purely knowing what this looks like on a graph. Okay, so can you guys think about what the graph of the absolute value of x minus 3 looks like? Where is it shifted? Not down, man. Yeah, it's to the right. Yeah, so it's going to be shifted to the right, and then we have that V shape, right? So at 1, we want to know what this slope is. What do you think the slope is? It is -1. Yes, it's going downwards. It goes down 1, right 1, down 1, right 1, down 1, right 1. All right, we've done plenty of these chart problems so far. So if we have h of x equals f of x over g of x, then we do the quotient rule to find the derivative, right? So we have h prime of x equals low is g of x times d high is f prime of x minus high is f of x, d low is g prime of x, all over the square of what's below. So we get that. All right, so then we're going to plug in 3. So we want to find h prime of 3. So we're going to find g of 3, which is 2. So it's on our chart. And then we want to find f prime of 3, which is 4. Minus f of 3 is 5. And then g prime of 3 is 7. All over g of 3 is 2 squared. So we get 8 minus 35 on top, which is -27 over 4. So our answer is A. Easy enough so far? Now the next one looks very easy. However, if you look at it, you do. It's a double prime, so don't be fooled by that. So we're going to do h prime of x first. Oops, h prime of x. Which is going to be first is f of x times the derivative of the second, which is g prime of x, plus derivative of the first is f prime of x times the second normal is g of x. And now we're going to do the product rule on each of these because we need to find the second derivative. All right, so the other class had trouble with this, so kind of do it along with me. All right, so for the first, the red rectangle, when I take the derivative, I'm going to do f of x normal times the derivative of g prime. What's the derivative of g prime? G double prime. So I'm going to do f of x stays the same times the second one's derivative is g double prime plus the first one I take the derivative, so f prime of x, and then the second one stays the same. So you guys all see that that is the derivative of the red box. Now we have the blue rectangle, which is never ending, is it? Good thing I'm not asking triple prime because that would be a mess. All right, so this one. So I'm going to have the derivative, or I'm going to keep f prime the same, so f prime. Derivative of g is going to be g prime of x, plus derivative of the first one is f double prime, and the second one, how it is g of x. So really, this term and this term are identical on the inside. All right, so now we're going to plug in 3. So h double prime of 3. If I have f of 3, so look back at your table. I have it in front of me. So f of 3 is going to be 5. G double prime of 3 is -2. F prime of 3 is 4. G prime of 3 is 7. And then I have that term repeated, right? 4 times 7. And then f double prime is -3. And g of 3 is 2. Do I have all those numbers right?
So you have 40.
It is 40, yeah. So 40 is your answer. Fun, fun, fun. All right, so it says using the table above, if h of x equals f of x squared, then what is h prime of 3? So this is where I've told you guys to treat f of x like sine of x. So if you can think about how to take the derivative of something like sine of x, right, then you're good. Because if that's really the same as like an f of x function squared. So its derivative would be 2, and then you still have sine of x, right? So that's like our f of x to the first, and then times the derivative of sine, which is going to be cosine, right? So that's how you would take the derivative. Looks like a factorial there. That was a first. That would be the derivative of sine, or sine squared. So we're going to do the same thing here. So when I take the derivative of f of x squared, its derivative is going to be 2 f of x to the first, right? And then times f prime of x, exactly. E and Speedy, are you guys speedy like this? Yeah, so f of 3 is going to be 5, and then f prime of 3 is going to be 4. So we get 2 times 5 times 4 is 40. Silly. All right, I would say on the test, do not just do it all in your head, because then I can't give you any credit for your work, right? So show some steps so I can give you credit. All right. All right, so this next one. So if I have h of x equals g of f of x, think about what the derivative is. Do you guys all know the derivative of this now? It's an important one. It's basically a chain rule, right? So think about something in the form like sine of another function. So sine of x squared plus 3. Its derivative is going to be cosine, so the derivative of sine, of x squared plus 3. The u part's the same, right? Times du. So if I do h prime, it's going to be g prime of the u part stays the same, so f of x, that was our u, and then times f prime of x, that was our derivative of u. Does that make sense? Did you guys get that? So this is where, like, students every single year are like, all of these problems, like number 2, 3, 4, and 5, they all say like h prime of 3 or h double prime of 3. It's an x value of 3. So why in the table do I have a column if you look at our table? So they're always like, why do I have this row that has x equals 5 when all of them say 3? It's because of things like this. So if you get on the AP test and you're like, why do I have this whole set of values? Right, you probably missed something. So go back and look for it. So it's right here. So we're saying g prime of whatever f of 3 is times f prime of 3. Well, f of 3 we find. So looking at your chart, do you guys see f of 3? It's 5. That's where the 5 comes into play. So then we have g prime of 5, which on the chart, g prime of 5 is going to be 3. No, wait, not 3. What am I? G prime of 5. Hang on, let me go back to my chart. G prime of 5 is going to be negative 4, and then f prime of 3 is going to be 4. So you get negative 4 times 4. So negative 16. All right, you got it? Your question? All right. Next up. All right, so this is a double chain. Do you guys all recognize the double chain? So I'm going to rewrite it as f of x equals, and I'm going to put cosine of 2x, and then all in parentheses, cubed. So we have something cubed. It's in the form u cubed. So the derivative of u cubed is going to be 3, whatever u was, squared, times the derivative of u. So we're going to have cosine of 2x. Jordan, put your computer away. Thank you. See, you knew I was going to say it already, right? Times 2. So it's like you're treating your new, like when you're taking the derivative of cosine of 2x, that's like restarting the problem and saying, okay, now I have cosine of 2x. What's its derivative? Well, it's in the form cosine of u. So cosine of u's derivative is negative sine of u du, right? So that's what we're doing. If you forgot the 2, you will get the answer wrong because both of these answers are up there. So we got to look for it.
So do you use the double chain when it's basically another
inside?
Inside?
Yeah, so something is inside and this is inside. Yeah, so it's like you have 2 u's, right? So we have pi over 6, so I'm going to do 3 cosine of 2 times pi over 6. What's 2 times pi over 6? Pi over 3, right? So I'm going to write pi over 3 squared times negative sine of pi over 3 times 2. Do you guys know these values off the top of your head? I know, the other class was struggling. Thank you. It is 1/2.
Good job, Fran.
And it is root 3 over 2. So I'm going to do a negative. You are, math star. times 2. I used to put people's names up on my bulletin board with math stars, but I don't do that anymore. I know, it took up too much time. All right, the 2's cancel. And then 1/2 squared is going to be 1/4, right? So I get 3 times 1 over 4 times negative root 3. So it's choice A. So if you had forgotten the 2 that was right here, you would have gone with choice B, and that would be incorrect, right? All right, the next one says, find all the points on the graph where there's a horizontal tangent line. Anytime you see horizontal tangent line, what are you thinking? Yeah, slope equals 0. So set your slope, your derivative equal to 0. So we have f prime of x equals negative 3x squared plus 6x plus 0, right? Derivative of negative 2 is 0. So we set f prime equal to 0. We can pull out a GCF, so I'm going to pull out a negative 3 and an x. So when I do that, I'm left with x minus 2. So I get x equals 0 and I get x equals 2. So that means there should be 2 points. We should have 0 comma something and we should have 2 comma something. So we can get rid of the onlys for sure. But you got to be careful. You can't get rid of the none of these. So we're not sure on the none of these. So we got to plug in to figure out what the y value is. And if you plug it in, if you plug in 0, you can easily see that's negative 2. If you plug in 2, you get negative 8 plus 12 minus 2, which is 2. So it also gives you that. So it is C. So I was telling them in the other class that when I taught at IU, I usually taught pre-calc. And the course coordinator, so like the person that was in charge of all the teachers, yeah, that's my teacher story. He didn't always check his keys, I guess. So like he would make like 6 different versions of the final because you would be crammed into one place, and he didn't want you to be able to see in any direction on people's tests. So he would like make 6 different versions of the test. But he would make mistakes like all the time, which I can't judge because you guys know I make mistakes, and I did that on your pre-calc final one year. I had a couple questions that were wrong. So I can't judge, but, you know, if I had someone else that was, like, teaching the course with me, I would totally be like, hey, can you check out this test? Can you write a key or whatever? And he never did that. So he would have answer choices A through, H was the last one, so A through G, and then he'd be like, okay, well, if answer choices A through G don't work, then H is going to be your solution isn't there. And so kids, sometimes that was the solution. Like sometimes none of the answer choices A through G worked. And then the answer just wasn't there, and that was the answer for that test. Isn't that annoying? Ugh.
Sometimes they made like none of the above.
Yeah,
They would
so.
other teachers to work for.
No, that's it. All right, so let's skip one. Let's go to one of these. So number 2, so consider the parabola y equals x squared.
Do we have to consider?
Okay, so we've done these before. So if I have y equals x squared, and it says show that the line through the point 3, negative 2 with a slope of negative 2 is tangent to that parabola. So 3, negative 7. So 3, negative 7 is not a point that's on this parabola. You guys agree? 3, 9 is on the parabola. So 3, negative 7 is somewhere down here. And so what it's saying is show that this goes through some point along the, I missed it, but whatever. You get what I'm saying. It's where you just do a really big point. Okay, so there's a couple different ways that you can do this. So the first thing that I would do is I would probably just do like the algebra 2 type thing and find what this equation of this line is, okay? So the equation of this line, you can do your y minus y1. So I get y minus a negative 7, so plus 7 equals negative 2 times x minus 3. And we can multiply out. And let's go ahead and get it in y equals form. So it's y equals negative 2x minus 1. Okay, so if we can show that this line is the same as the line that's tangent at this point, then we're good. Yeah?
How did you get negative 1?
I subtracted the 7 over. Right. So,
Oh, right.
mhm.
You know, algebra 1.
That's okay. All right, so let's see. So I want to show that if I have y equals x squared, and I take the derivative, I get 2x. Okay, my slope at that point is negative 2, right? So if I have negative 2 is equal to 2x, what x value is that hitting?
-1.
Negative 1. So the point at negative 1 is negative 1, 1, right? Y equals x squared. So this would be the point negative 1, 1. So basically you want to show that that line that I've drawn, that red line, is the equation of the line through negative 1, 1. So then you'd say, okay, well I have y minus a negative, or y minus 1 equals m, which would be negative 2, times x minus a negative 1, which is plus 1, like that. And we solve it out. So I get negative 2x minus 2. And then I add the 1 over, so I get y equals negative 2x minus 1, like that. Are these the same lines? Yeah, so those are the same. So the line that went through negative 1, 1 was the same as the original line that went through 3, negative 7. All right. So B says, well, find another line through 3, negative 7 that's tangent to the parabola. So this is saying, oh, there's another line that would go in that direction. That looks perfectly vertical, but it's not. So we need to find that. And we've done ones like this in class before. Do you guys remember these? So it's where we found our slope was 2x. And then instead of plugging in like a certain slope, we plugged in a kind of a vague slope, this 2x slope. And for m, the derivative of y equals x squared. So we're going to plug in 2x temporarily because we don't know what x value it's going, like we don't know what this point is. It's just x comma x squared, right? And then we plug it in. So we're like, okay, I have 2x. I'm going through 3, negative 7. So I have 3, and I have y minus a negative 7, y plus 7. And then do you guys remember the last step that we did in order to solve this? Yeah, we replaced y with x squared. So we have x squared plus 7 equals 2x squared minus 6x, like that. And I get everything on one side. So I have 0 equals x squared minus 6x minus 7. And I factor. So I get x minus 7 and x plus 1. So I get x values of 7 and x values of negative 1. So that's at the point 7, comma 49. And it's at the point negative 1, 1. The negative 1, 1 is not the one that we want. That's the one we already had. Do you guys agree? See negative 1, 1 up here? So that's out. We don't do that one. So this is the other place. So the question is, find another line. So last step, you have 7, comma 49. Do you know the slope at 7, comma 49? It's 14 because you plug into the 2x. And then you write your equation of your tangent line, y minus 49 equals 14 times x minus 7. So putting it all together. And then the question C says, is there a third line that would be tangent to this parabola? No. Why do you know there's not a third line?
Because it's impossible to have more than 2.
I don't know. You could have more than 2. Right? Could I have here, and I could do here, do there. I mean, there could be lots of things, but not for a parabola. So justify your answer. So we're going to say no. The only solutions were x equals 7 and x equals negative 1. Right? The only solutions to the above equation were those two things.
Is that justifying it?
That's probably not justifying it very well. I could probably say that a little bit nicer, but we'll go with that. All right, does that make sense? All right, and then the last one that we have is a velocity question. So it says between 0 and pi, a particle is moving along the x-axis. The particle's position is not given. The velocity of the particle is 3 sine of 2t plus 1. So find the average acceleration. Okay, so we are not going to actually take the derivative of this. I know that acceleration is the derivative of velocity, but since I have the word average there, what I want you to find is the average rate of change. And what we're finding is the average rate of change of velocity. So that's important. So I'm going to do v of pi minus v of 0 all over pi minus 0. And when I do that, I didn't give you units, but velocity is typically in something like meters per second. And the bottom from 0 to pi is talking about a time, so that would be in something like seconds. Do you see when you have a rate that's meters per second divided by second, what will your units be?
Meters per second.
Meters per second squared, which is an acceleration. Does that make sense? So when you set it up as the slope, we're asking for the slope of velocity. The derivative of velocity was acceleration, okay? So it's the same thing. So when you see average, think of average rate of change. And then don't think of the actual thing it's saying. Average acceleration, you want to go one derivative before it. So not a derivative before it, but one function before it. All right, so here we go. So if I have v of pi, I'm going to have 3 sine of 2 pi plus 1. And then v of 0 is going to be 3 sine of 0 plus 1 all over pi minus 0. And it's actually easier than you think it is, just when you know the answer right away. Sine of 2 pi and sine of 0, what are both of those? 0. So we have 1 minus 1 on top, which is 0. So 0 over pi is 0. So that is our average acceleration. So that can happen. Basically, it's saying that you're not speeding up or slowing down on average, right? You could speed up a little bit, and then you could slow down by the same amount, and then that would be an average acceleration of 0. All right, so in the time interval 0 to pi, the particle changes direction twice. So whenever you say changes direction, what function are you looking at? The velocity, and you want to find when the velocity it goes from positive to negative, so it has to go through like 0, right? Positive to negative or negative to positive. So we want to find when v of t is equal to 0. Okay, and this would actually be a calculator question, and I'll show you why. Because we have 3 sine of 2t minus 1 equals 0. And if you started to solve that one by hand, you get a value that is not a unit circle value, right? So you would need your calculator anyway to do inverse sine. But when you do inverse sine on a calculator, it only gives you one value. Do you guys remember that? And there could be more than one value that makes that true. So I would just graph this. Sarah, do you have a question?
Yeah, I think it should be -1.
I think it's 1. Oh, was it plus 1 here? Yes, thank you. All right, so I'm going to leave it. I'm not going to even do this step where I subtract it over. I'm going to just plug the velocity function into a table, or into my calculator. Okay, so, and I also want to mention, so Syra caught my arrow. Did you guys see what I did? I had made -1 there instead of +1. I would have gotten full points for that setup, though, because I wrote this. Okay, always write the most basic form first, because if you make a mistake and leave off a negative, which you probably will, you'll be stressed on the test, right? Then you will miss that point. Okay, so we'll talk a lot about that throughout the year. All right, so I'm going to go ahead and graph this. Go ahead and graph with me. Everybody should try the graphs, as I say. Graph along with me. Syra, you can grab that one if you want.
I can just go to my locker and get
Okay, so we go to y equals, we're going to put in 3 sine of 2x plus 1. I make sure my mode is in radians. I'm good. And then the interval is only 0 to 2 pi, so for my window, I'm going to go ahead and change it now. And I'm going to make my x min 0 and my x max pi.
It's 0 to pi.
0 to pi, thank you, sorry. So I'm good there. So then I hit graph. And it goes up, and then it comes back down. So what this graph is telling us is that the velocity is positive on this interval, 0 to something. And then it's negative from here to here. And then it's positive again. So we got to find the location right here, and we got to find the location right here. So we're going to do second, trace. We're going to find the 0. Left bound, so get on the left of what you want. Right bound, get on the right of what you want. Guess, I usually try to go right where you think it is. And enter. I get 1.741. Did you guys all get 1.741? All right, that's the first one. Okay, because you are in degree mode.
I'm in radian mode.
It should not give you a line. I don't know. Did you put your x in?
3 sine of 2x plus 1. Yep.
I don't know. All right, and then you do the second one. So second, trace, intersect, and go over and find that one. Or not intersect, 0, I mean.
Yeah.
Here, Ian, bring it up here. Bring me your calculator.
No, it's fine. I fixed it.
You got it. What'd you do?
I don't know, but it's working now.
Did you do alpha x maybe? I don't know.
Maybe.
That shouldn't change it. I
I'm
wouldn't
not
think
sure.
so. All right. 2.972. You can actually round or truncate, so either answer would be fine. So we want to find the interval where the particle is moving backwards. So it's going to move backwards from here to here. So we're going to say on 1.741 to 2.972. That would be the interval. And then the last part says, when is the particle moving at its greatest speed? So how is speed related to velocity? Yeah, what did I do? Yeah. Now, speed is equal to the absolute value of velocity, so you have to be kind of careful because sometimes, so looking at this graph, sometimes it goes up a little bit and then it goes down really far. So if you took the absolute value, you would actually find the minimum. So sometimes what I will do is I will instead go back to my y equals, and you can do insert. Do you guys see second insert is the delete button? And then I'm going to put an absolute value by doing math, go over to number, absolute value. You did that? Parentheses, and then that just takes whatever was below the axis and it flips it up. So then you can see the speed. And then you can basically compare the two heights and say, oh yeah, this one over here is definitely higher. So we're going to do second trace. We're going to find the maximum. Did you already find it? 0.785. All right, so it's going to be right there. So you can do left bound, enter. You can do your right bound, enter. And then guess. Usually I put the guess where it's supposed to be, but you don't have to. All right, so 0.785, I agree. All right, good? All right, that's it. Not necessarily. If this had been something where I could solve it, like if it was like sine of 2t equals root 2 over 2, right? You could find that using your unit circle. A lot of times they will be. Yeah, if it was saying when is it moving at its greatest speed, you could take the derivative of velocity and find that maximum point. So that would be one way you could do it. But I think calculate it right now.